This is the Progress Check 1 summary video for exponential growth and decay. So we're going to start with growth. In this scenario, in 1985, there were 285 cell phone subscribers in Centerville. The number of subscribers increased by 75% per year after 1985. And it's asking us how many cell phone subscribers were in Centerville in 1994. So our first step is to identify what the start value and the multipliers are. So our start value is going to be 185 because that's initially how many subscribers there were in 1985. Our multiplier, you always start with the whole, so 100%. And the question, we're seeing how much more is it increasing by each year. In this case, it's 75%. So we add those two together and end up with 175%. The only thing is we're not done. We need to change that into a decimal. So we end up with 1.75. Our next step is to write the rule. So in this case, we have your start value, which is 285 times the multiplier to the x power, so 1.75. So y equals 285 times 1.75 to the x. Our next step is to start filling out the table. So when x equals 1, you have y equals 285 times 1.75 to the power of 1, which is 498. And then you can put that in your table and keep on going. For x equals 2, you have pretty much the same thing, but wherever there was a 1 last time, you put the 2 in. So 285 times 1.75 squared, which is 872. Same thing with 3. You have 285 times 1.75 cubed, which is 1,527. And then you keep on filling the table out for each year until you hit 1994. We're still not done. We have to go back to the question because it's asking us how many subscribers were in Centerville in 1994. So, if we look at our table in 1994, there were or will be 43,871 cell phone subscribers. Now for decay. In our scenario, each year at a local country club, there's a tennis tournament starting with 128 players. During each round, half of the players are eliminated. So we need to figure out how many players remain after 5 rounds. So again, just like with growth, we need to first identify our start value and our multiplier. For this one, we start with 128 players, so that's our start value. Our multiplier, instead of adding, you're seeing what you're taking away, what you're decreasing. So you have 100% minus 50%. The reason you're doing this is you want to find out how much you're actually keeping each time. In this case, you're keeping 50%. Now, just like with the growth, we have to change it into a decimal, so you end up with 0.5. Next, we have to write the rule. So, y equals 128 times 0.5 to the x. Thirdly, we have to fill out the table. So x equals 1, y equals 128 times 0.5 to the power of 1, which is 64 players. When x is 2, oops, I kind of jumped ahead. When x is 2, you have y equals 128 times 0.5 squared, which is 32, and then when x is 3, you have 128 times 0.5 to the cubed, which is 16. And then you keep on filling out the table until you get to 5. Just like with growth, we need to do our final step, which is answering the question. The question asks how many players remain after 5 rounds. If we look at our table on round 5, there's 4 players left. So you would write a sentence, after the 5th round, there are 4 players left. I hope this helped you understand growth and decay more. Let me know if you have any questions.